Now, our lecture is about quantum tunneling. Quantum tunneling is one of the most fascinating and bizarre phenomena in the world of quantum mechanics, where very tiny particles devise the physical laws we know from our everyday lives. Imagine tiny particles like electrons facing an atoll safe wall. In the normal world, it would bounce off or stop, but in quantum, the realms it can leaks through it, a ghost passing through a solid wall, so emerging safely in the other side. The beginning of the stories and difference between the big and small worlds. In our daily worlds, if you throw a ball into walls, it is bounce back or shatters because the energy is not enough to pass through it. This is called classical physics, developed by scientists like Isaac Newton, and it is work perfectly for large objects like cars, tracks, or planes. But when we go down to the level of atoms and smaller particles, everything changes, every law is changing. They're practicals. Practical doesn't behave like solid balls, but like mysteries where failing space able to appear in completely unexpected place. Quantum tunneling is a prime example of these mysteries, where leakage happens naturally without any supernatural forces just because of the natures of these waves. How does this strange leakage happens? Imagine a particle, a sea wave, moving towards a tall rocky structure. Normally, the wave crashes against the rocks and breaks, but a small part of it is always sneaks behind the rocks and reaches the other shores. No matters how thick the wall is, how quantum scientists think of the particles. Their wave doesn't stop all batteries at the barrier spot perturbates it slightly and continues, giving a chance for the particles to be detected in the other side. This change is very smooth. If the period is 6 or high, but it's always shared and with the many bands leakage succeeds and ends. This isn't a fantasy, it's proper fact observed experimentally for decades. Tunneling in nature is the secret of the universe. Looks at the sun, the source of our life deep inside in nuclear fissions occur to make it shine. But protons, hydrogen practice face a massive period of repulsive electrical forces without quantum tunneling. These practicals couldn't get close enough to fuse, so the suns wouldn't have been burning for billions of years. Similarly, in heavy atoms like uranium, tunneling helps stabilizing the nucleus as alpha particles group of two protons and the neutrons slowly leak out, causing the natural radiations we see in ancient rocks. Even in human skin, tunneling happens between two enzymes to speed up chemical reactions in our cells, making life possible. Amazing application in modern technology. Today's code engineers exploit this phenomenon in everyday devices. For example, in smartphones and computers, tunnels diodes allow super fast electric current to pass through the tiny plastic batteries, making chips faster than smaller. In scanning, tunneling microscopes that divide and sends electrons through the quantum tunnels to wireless and atom surface, imaging details finer, finer than a human hair by billion of time, which helped develop the new nanomaterials. Also in energy storage devices like hydrogen batteries, atoms leak through special walls to generate clean electricity, and even in quantum computing, which could change the world in the future's qubits rely on very similar tunneling principles to store information in extraordinary ways. The controversy and the myths around tunneling. Some people mistakenly believe that tunneling allows faster than light travel or violent casualty loss, but this is not enough true. The particles cross the barriers at super speed. It suddenly appears on the other side as probability and information doesn't travel faster than light. This phenomenon has sparked major psychological debates in this world designed to allow chance, or it is evidence of nature's deep. Scientists like Richard Feynman described it as nature awareness, emphasizing it is a fundamental part of our understanding of the universe. As the in quantum tunneling reminds us that the small world is full of surprise and future technology is built of this audio to this. If you are interested in quantum physics as engineer, it's a gateway to understanding coming innovations like in quantum computer and the clean nuclear energy. So if you good at math and physics, the route is is opening is tremendous for you to become a professional engineering, so you can become a professor in Harvard University. You have a bright futures. I wish any good to use and meet you. See you. Thank you. See you later. Bye.